Hello and welcome to TGIK episode 47. I'm your host today, Kris Nova. George and I were just goofing off before TGIK and it was a lot of fun, so I'm like in a super great mood today. We were talking about maybe getting some intro music whenever we start TGIK, like wherever you cut over and then there would just be like this big like a cool song. So I don't know, if folks have an idea for good intro music for TGIK, let us know and maybe we can like figure out a way to like get that up and running. Also, my blood sugar is pretty low today, so I'm going to be drinking a lot of really sugary tea, so I'll probably be really excited today. So anyway, let's see what folks are saying in chat. Everybody knows this is my favorite part of the week, so let me scroll down here at the bottom and see what folks are saying. Lamatti, first in line. I want to like check metrics on how many times Lamatti is the first person to join TGIK and say hello, happy Friday to everyone. It really is like my favorite part of the week to watch folks join, and it's always nice to see Lamatti, so it's really good to see you again. Olav says, yes, I second that. Suresh, hi, joining from Hamburg. Jonas, hi from Dubai. It's midnight here. Thanks for joining, Jonas. Thanks for joining at midnight, particularly. That's pretty intense. I don't know if I would be able to stay up that late. I'm usually out by like 8 or 9 o'clock every night. Let's see. Cynthia says, happy Friday. George is on the Heptio account. He says, how's everyone doing today? This is George. I'll be helping Kris with notes and general stuff today. Lamatti, it dawned on today that TGIK is just over a year old now. Maybe someone at the Heptio office can hit the gong to commemorate the anniversary. Yeah, if anybody at the Heptio office is watching, totally grab the gong and come bring it in here and we can like hit the gong. I don't know if that breaks our sales rules or not. Whatever, we can totally hit the gong. Also, I start my vacation after today, so if you accidentally grab a beer as well, I would not be upset. So anyway, we have Darmet, hello from India. Lamatti used to crack me up when the gong would go off randomly during the first few episodes. I lost my spot. Here we go. Okay, so Tobias says hi from Berlin. Lamatti, happy Friday, George. Greetings from Copenhagen. Yeah, that was classic. Evening from Scotland. That's cool. Hi from the Starbucks Support Center. Hi, friends at Starbucks. Jason, good to see you. Miguel, hi from Mexico. Hi, everybody. Happy Friday. Hi. I'm reading off all these because it's my favorite part of the week and I actually get really happy. Nice to see you, Kris. Arnud says, hi, folks. Olaf from NYC. Morning all from New Zealand. Carl, thank you for joining from New Zealand. Timmy, happy Friday. Howdy, Kris. Saeed, hello from London. George says, another Heptio update. All right, everyone, if you want to help with the note-taking. Okay, so yeah, I should pull up the note-taking, but I want to finish telling folks hi. Hi from Bangladesh. Good to see you, Abu. Cheers from Toronto. Hi, Roy. Hello from Romania and from San Francisco. Happy Friday. Hey from Seattle, right next to HempFest. I didn't know there was a HempFest going on right now. That's exciting. And Automate, hi from the Netherlands. So folks joining from all over the world. Thanks for joining. And then really quick, I'm just curious, I don't think we've actually like asked, done like a poll the audience thing before. How do folks usually watch TGIK? Like, are folks on their computer? Are they watching on a TV? Do they watch it on their DVR? Just trying to get an idea of what our audience looks like as we start to move forward. And also, we have some exciting like surprises for TGIK coming up in the future. I can't say too much right now about it, but having an idea of which media channels people are using would be helpful. So Todd says hi from SoCal, laptop, big screen, computer. So yeah, I'm going to let folks answer that question kind of concurrently. And without further delay, I'm going to switch over to my screen and we're going to look at the HackMD and start going through This Week in K8s. There's my screen, and then there we go. Okay, so we want to go to the HackMD, which is here, and I'll just close everything else so that we can start fresh. So for those folks at home who don't know, we use this really cool tool called HackMD, and I've started lobbying for this in some of the Kubernetes open source calls. This is a collaborative markdown editor, so it's like a hybrid between too much sugar tea. It's like a hybrid between Google Docs and like the GitHub Markdown editor. So George and myself are both able to come in here and edit this. And if you have anything you want to add as well, this is a good way for you to share ideas, ask questions, add notes as we go through today's episode. And this becomes a resource for everyone. So it's my responsibility, it's George's responsibility, it's your responsibility to help take notes if there's something you would like written down or you feel like folks would benefit from knowing. Okay. So we usually do this week in Kubernetes, which we're going to go through. We have a ton of stuff this week. It's been a busier week, which is awesome. And we usually do, like, I've gotten in the habit of doing like a Golang update. And I've been really busy at the office this week trying to get ready for my vacation, so I didn't have time to prepare any Golang updates. So what I was wondering is if folks could drop in the chat as well any of the new features in the latest release of Go that looks exciting or confusing or scary to them. Mention the feature and mention what your thoughts are on it, and we can bring that up together and we can just sort of like look at some of them and talk about some of them for our Golang update today. So anyway, week in review. So the first one we have here is we have Kubernetes deconstructed. So let's pull this up. Oh, it's a video. Okay. So it looks like it's a video. It's Damo, and let's see what this says.
That application is on them. So the deployment, when he makes these pods, will label it with these two labels.
Okay, so it looks like he's just going in and talking a little bit about Kubernetes and how it works and explaining all the different primitives and how they relate to each other. Which, honestly, for folks coming to Kubernetes for the first time, the slide I even landed on is already like a really great example. But it's really important to kind of go through and learn this stuff the right way on day one, because there's a lot of stuff going on behind the scenes and a lot of kind of, I wouldn't say magic, but a lot of things that if you don't know about can be frustrating or confusing. So getting a nice solid education up front is always helpful and preferred, especially in a system that is complex as Kubernetes. Okay, coming up next, there's an associated GitHub project with this one. Okay, and I'm assuming this has got a caddy file, it's got some Python scripts, layers, assets, demo. Okay, this has just got resources from the demo that I think we're looking at in the video. So that's always cool. It's always nice when people share their demo work. Okay, let's move on to the next one, but before we do that, let's see what folks in the chat are saying. I gotta scroll pretty far up. Man, people are chatty today. Okay. Miguel says watching on his second monitor. Rory's watching on their desktop computer. Okay, so we have a lot of computer users. Lots of laptops. I see 3 laptops, 4 laptops, an iPad, another computer, another laptop. Okay, so Automay says all reminds me of Etherpad, which is older than Google Docs. Paul says was watching TGIK from iPhone a lot previously, would sometimes be watching while moving around. Got a laptop, so I'm using that more now. So yeah, it looks like folks are mostly using computers and laptops, which is helpful. Thank you for sharing that wonderful piece of information about how you're watching TGIK. Okay, next up we have Cube Hunter. Oh, Lamati says. Oh yeah, okay, so Mark's here with the gong. Also, I didn't realize you were watching TGIK. Do you want to hold it so I can hit it really quick?
I think it's necessary.
Okay, thanks. Everybody, this is my co-host, Mark, for today.
Well, hello.
Hi. Okay, so congratulations for 1 year TGIK. Also, where's my beer? I'm just kidding.
I would deliver, but I didn't get that message.
Okay.
The
yeah.
mallet.
Here's your mallet.
All right,
Okay.
sweet. Bye.
That was just for you, Lamati. Okay, so coming up next, we have Cube Hunter. Cube Hunter, an open source tool for Kubernetes penetration testing. Ooh, this is exciting. I love good pen testing tools. They're always really exciting. I used to work on some pen testing tools when I worked on a HIPAA compliant thing years ago when I first started coding. It was like my favorite part of my job was trying to figure out clever ways to access the system and exploit random bits of information. But this is cool that there's an open source framework or tool out there that looks at pen testing. Oh, and this is brought to us by our folks at Aqua. Okay, so this is really cool. I kind of want to go check this out now. I wish I had more time in the day. See, PCI compliance guide. I know pen testing is really big for people who need to be PCI compliant because you want to make sure that your systems aren't vulnerable and that you are staying up to date with vulnerabilities and CVEs whenever they happen. So that's cool. That's really exciting that there's a Kubernetes specific one, and thanks to our friends at Aqua. I'm not going to sign up for the blog. Thanks to our friends at Aqua for bringing this to our attention. Coming up next, we have SUSE switches to kubeadm. I wonder what this is. Okay, so it looks like it's an open source blog from OpenSUSE, which I say OpenSUSE. I've heard people say OpenSUSE. Feel free to tell me what you think in the chat, but I'm probably going to still keep saying OpenSUSE because it reminds me of Dr. Seuss. Anyway, exciting new direction. A stable base for the future. Reviewing our initial premise. The world has shifted. Okay, so this is all talking about Kubernetes. How can I help? What is this? Oh, okay. It's been over a year since we started the Cubic project, and now we're looking back over the last months and evaluating what we've succeeded. Okay, not only is Cubic MicroOS now a fully integrated part of OpenSUSE. Okay, so this is an update on the Cubic project, not kubeadm. I think, did this say kubeadm? SUSE switches to kubeadm. Okay, cool. So I guess we're using kubeadm to help set up Cubic, I'm guessing. Somebody correct me here. Oh, here's some kubeadm language here. This is one of the primary motivators for creating Vellum, a key part of the SUSE CAS stack. However, these days there are multiple tools, including the increasingly pervasive kubeadm, which is used standalone as the integrated part of many larger solutions. Okay, cool. So this is just talking about how OpenSUSE and kubeadm are now working well together. And from the sound of the title that George put in there, it looks like we have OpenSUSE support in kubeadm, which is cool. Pat on the back to our friends at SIG Cluster Lifecycle. Also, sorry I've been missing a lot of meetings lately. Like I said, I've been crazy busy at work. But I'll come check it out and say hey one of these days. Okay, so next we have EKSctl. Oh my gosh, I love Ashley Gophers. Every time I see him, I get so happy. Okay, so let's see what we have here. Major release, first major release, 1.0. So if you come to the Weaveworks EKSctl, it looks like Weave came out with their first 1.0. I want to look at the code here. I always like looking at Go code. And of course, we all know when I look at debugging software for the first time, the first thing I want to find is the main.go, which should be in here somewhere. And yes, we're using Cobra. And what do we call it first? Oh, it's just a help command. Okay. So anyway, EKSctl 1.0, thanks to our friends at Weave. What's next? We have a Sonaboy office hours if you missed it. So you can come here and check it out. I think we're still waiting on doing Sonaboy and TGIK, although I really want to demo it one of these days, and I know we keep saying that. Like, as soon as I get back from my vacation, I might do, and we wrap up the CNI, I might do like a Heptio tooling TGIK series or something. So hats off to our folks at Sonaboy. Docker Hub maintenance on the 25th of August. Okay, so folks who are pulling Docker images from Docker Hub, looks like Docker Hub has a planned outage, so be prepared for that. Make sure your systems teams know about it. Feel free to share this link and maybe shoot an email off to your engineering department and saying, hey, just a heads up, you might not have heard about it, but it looks like Docker Hub is going to have some planned maintenance. So that's good to know. I know I store a lot of my container images in Docker Hub. Kate's 1.13 alpha is out. I can't believe we're already on 1.13. How does this keep happening to me? And it looks like we have an alpha branch here that folks can start tinkering with and trying to find new and exciting ways for us to improve Kubernetes. So we had, I think I'm going to say this right, Aliciano pinged me in Slack, I think last night or the night before, and said, friendly reminder, COPS 1.10 is out. I think this is another testament. I mentioned this when we were doing the COPS episode a few weeks ago. You know, COPS is, I wouldn't say like very far behind, but notably behind the rest of Kubernetes. We just had 1.13 alpha released in upstream Kubernetes, and COPS is now on version 1.10. The reason for that is because we try to have stability in the COPS project, and there might be some other reasons that I don't know about. Anyway, 1.10 dropped like 2 days ago, and I actually used 1.10 to deploy a cluster that we're going to be looking at later today when we actually get into Cilium, the whole reason we're here today. So next we have the Cilium install guide. Okay, I have all of my Cilium notes here, but I want to talk, I want to make sure there's nothing else I'm forgetting. Okay, this is all Cilium stuff. So I guess I'm going to move over to Cilium. I didn't see too much in the chat about Go, so maybe we can do an episode later when I get back, or maybe Joe can do it as well, where we look at some of the new features of Golang. I know it's caused quite a ruckus on Twitter, so I'm actually kind of curious. And again, just haven't had time to check it out yet. So anyway, let's talk about Cilium. So if you go to cilium.readthedocs.io, the first thing I wanted to point folks to is this Kubernetes COPS installation guide. Let's see, what does George say? George says, if you have episodes ideas, please file it as an issue and we will check it out. And yeah, so that's the GitHub issue tracker here. So let's see if I can open this up. It opened up here, but I can move it up here. Whoop. There it is. So we already have 43 of these issues, but if you have an idea for an episode, we do actually come through and look at these. There's no real rhyme or reason to how we pick an episode other than like it's just what we're feeling and what makes sense. And I think sometimes we try to do like small mini series about it. And I know I'll come through this thing like Tuesday morning sometime, and I'll just kind of scroll through and see if anything looks exciting or if I've heard anything about one of these projects. And then ultimately we end up making a decision. And our inspiration for this week was after we did Calico last week. Jesse Frizzell on Twitter followed up on one of my comments about Calico and said, make sure you check out Cilium. I came in here and sure enough, somebody had opened up an issue on Cilium. Let's see if I can find it. One closed. Yep, this was Lamati. So you can see that we'll actually come through and we'll find your episode idea and we'll actually do it and close it, which is exciting. So feel free to contribute there. It is also a good place just to like ask questions or if you have any thoughts about the episode, add them there as well. Okay, let's close some of these tabs so that we don't get super confused. Okay, Kubernetes 113, COPS 110, and here's our installation guide, and I'll leave up our HackMD here in case we hit anything throughout the episode. Okay, so I'm gonna do a little bit of storytelling here and talk about my week and getting Cilium up and running. The reason I wanted to start off with the Kubernetes COPS installation guide here is to let folks know that out of all of the avenues in which I looked at demoing Cilium this week, this is the one I ultimately picked, although I did try it setting up Cilium with Kubicorn, and we're going to actually look at that in that whole process and see where I got off into the weeds and actually see where I had a little bit of trouble with TLS certs, and we're going to talk about how Cilium is attaching to etcd, and we're going to learn about the etcd operator that's coming out in the next version of Cilium that should solve a lot of these concerns, but I still think it's an important like engineering rabbit hole to go down, so we're going to look at this other cluster I set up not using COPS and kind of poke at that before we actually take Cilium for a drive on our COPS cluster that I already have up and running. So anyway, if you want to demo Cilium, I strongly suggest you start here or start with Minikube. In our case, I didn't want to do Minikube because I wanted to see how CNI was working in a cloud provider. In this case, we are running in Amazon. So we have, and actually I can show you because I have my terminal right here. We have a very small cluster running in Amazon. And the reason that I created such a small cluster is I wanted to have a really solid idea of where all of our work was going to be running so that we can actually look at the underlying file system. So we have one node so that I can SSH into that node, and as we start to deploy things on Kubernetes, we can be confident that it's going to run on that node, and we can actually see what Cilium is doing behind the scenes. When I first did this, I had 3 nodes up and running, and I found myself constantly like SSHing into different nodes because who knows where my pod would get deployed. The Kubernetes scheduler would do a great job at distributing that workload, and it got to be pretty annoying, so I bumped this down to 1. So if you want to replicate anything that I'm doing, it might be handy to just have 1 node as well. Okay, so let's go back to our docs. And I want to kind of walk through the COPS cluster setup that I did so folks can see exactly how I got my cluster up and running. Okay, so here is what I did. Is I exported the name to tgikates.com-cilium.kates.local. This suffix here at the end is important because this tells COPS that we want to use the gossip protocol, which is, I think, what is somebody saying? How I got it running. Okay, thanks. Anyway, that tells COPS to use gossip. So then I did this COPS create cluster. The COPS state store I have exported here. So if I get in my terminal, I can do export, let's do env pipe to grep -I, and we'll look for name. And I hope I'm not showing secrets here. I don't think I am. And we can do COPS as well. Okay, so you can see Kris Nova COPS, and then I have COPS future flag, and then I have this old environmental variable from when I worked at Microsoft still in my bash RC, apparently. Anyway, so those are environmental variables I have set. Let's go back here. And I did node count is equal to 1, which that solves the problem of ensuring that our pods are running on the node we're SSH'd into. We're just running some T2 mediums for both our master and our nodes. And for our master zone, originally the documentation had this running in HA. Again, I wanted 1 master because it's just going to make demoing a little bit easier, so I bumped this down to just using 1 zone. And then I did the same zone for our nodes as well. I had to look up this image ID, so if you pull up the documentation here, you can run this command, and I'll just go ahead and run it. It actually works right out of the box. Where did it go? Here it is. And let's go back here and run this command and give us a little bit of space there, and poof, there's our image. Going back to our documentation, I plugged that in here. I did -- override, which we were talking about this on a open source call the other day. This is a handy flag for COPS users because it allows you just to override arbitrary values in the spec at creation time. We tell it we want to use Kubernetes 1.3 or 1.10.3, and we apply some labels and give it a name. Lamati, which distro and kernel are you using on your control plane and worker nodes? Lamati, that is an excellent question. So again, this is a little bit of storytelling. On Wednesday or Thursday this week, I tried to deploy Cilium, and I tried to deploy it on Ubuntu 16.04. That was running the the Linux kernel 4.4, and that was incompatible with Cilium, and it was kind of hard to debug because the pods would exit like within moments of starting. So I actually discovered this really handy command here that I'm going to show folks that I did not even realize was a thing, but it's really, really handy if you have pods that are like only running for a split second. You can do kgetpo. Let's do all namespaces. All namespaces. I got to have a pod here somewhere. Okay, good. So yeah, we can do this Cilium pod. Just for the sake of an example, you can do kgetpo -- previous, the name of a pod, and then the namespace here. And this will actually, and I'm sorry, it's not kgetpo, it's klogs, or log. I think it's log singular. Either way, this will actually get the logs from the previous pod running for whatever like deployment or daemon set or stateful set you have running there, which is handy because that was able to tell me that Cilium was actually exiting because I was running an older kernel. Anyway, to answer your question concretely, we're running CoreOS. I forget which version of CoreOS we're running, but we can uname in just a second when we SSH into the master in the node. But I was able to get Cilium pretty close on an Ubuntu 18.04 cluster as well, which had a newer kernel that Cilium was able to use. So I think CoreOS, something that we're about to find out, and Ubuntu 18.04 are both viable options for running Cilium. Anyway, great question, Lamati, and I'll drop a uname-r or a uname-a into the terminal as soon as we SSH into one of our worker nodes. And if I forget, feel free to just remind me. Okay, so let's go back to our documentation here. So that was our cops create command. Then you like have to do this weird edit thing where you come through and you do edit, and then you like paste this in, and it's YAML, so like you have to make sure your spacing's correct, and you like override the CRD validation. And then I guess the version of Cilium that COPS ships with today is outdated. So you have to like run all these other commands here to like get everything up and running and to make sure you're running like a recent version of Cilium. Anyway, like I'm gonna do the cooking channel thing and be like, and it's done, because it's totally done. So if we come here and we can do kgetpo -namespace cube system, we can actually see, oh, this is like annoying. Let's try that. Yeah. And let's try this again. Okay, that's much better for me. You can actually see that we have some Cilium pods running, and that's good. That means we have Cilium up and running on the system. And I guess now would be a good time to actually, let's see what we have here. Oh, George is just taking notes. Okay. Now would be a good time to SSH into the node so we can actually start seeing. So I'll drop that uname now. So we want to go into our Amazon and we want to get some information about our master and our worker node. I have a lot of instances running. Sorry, Heptio billing. Not sorry. Actually, I'm a little sorry. But I'm going to turn both of these clusters off when I get done today, so they're not going to be running for very long. So the COPS one that we want to do is this master here. So originally, the Cilium documentation suggests that you deploy with -- private equals topology, which is a fabulous feature that I coded into COPS in the long ago that allows for all of your EC2 instances to run in a private subnet, and they actually don't have a public IP address. So the only way to gain access is with a Bastion server, and that was, again, causing a little bit of problems for me. I wanted this demo to be quick and dirty, so I removed the -- topology private flag from my COPS create cluster, and now we have a public-facing cluster. So anyway, we're going to SSH into our master really quick. Looks like folks are saying something. Let's see what it says. It's working on Ubuntu 16.04, but you have to upgrade the kernel to something greater than 4.8. Thank you, Simon. And yeah, I was like not about to upgrade my kernel, so I just like picked a different AMI and redeployed, and everything was happy. Okay, Lamati says, is that due to a specific eBPF feature, or is that included in 4.8? I'm assuming so. I know BPF is very tightly coupled with the Linux kernel, so I'm assuming that there's some sort of feature or code in there that the BPF system is using. And I bet if we looked in the repo, we could actually find it, because there's a lot of C code in the repo we're going to look at a little bit later in the episode. And yeah, Simon confirmed it as well. Okay, so let's open up a new tab here. I wish that it would preserve size, because I feel like I do this every episode where I have to like scale and then resync it back. Anyway, we can SSH, so core is the user here. Shout out to the Heptio field engineering team who helped me figure out that it's core is the name of the user and our public IP address. And we can say yes and yeah. So what does it say here? CoreOS container Linux stable 1807.0, and let's do a uname A, and that should give us a little bit more information. It looks like we're running 4.14 CoreOS kernel here. So hopefully that answers your question, Lamati. Let's see what Daniel says. The kernel has base feature set from BPF side. Yes, 4.9 is also LTS. Okay, so 4.9 is just long-term support, so that's probably why that one is relevant. Okay, so this is our COPS cluster. And if we actually go in and we can look at etc, we can go to, what is it, etc CNI? Yeah, net.d. Oh, let me sudo up first. Change directory, etc CNI net.d list, and there's our Cilium conf, and I bet if we go to opt, CNI ben list, here is, and we looked at a lot of this in our last episode, here is like flannel for instance, and if we run a different one, like if we run Cilium CNI.old, we should get the exact same output as well, and that's because the CNI protocol is actually execs out to the CNI plugin, and it expects it to speak some sort of standard API. So that's why, regardless of which CNI plugin you're running, you're going to get the same output because it's all standardized. So anyway, and you can see more about that and how CNI is sort of set up and how the kubelet registers CNI in the previous episode that we did on Calico. I'm not going to go into a bunch of it. I'm just going to kind of assume folks remember that, or at least can go look it up. And if you have any questions, just drop it in the chat as we kind of go through this. So anyway, we have CNI up and running on the host system. So I'm going to take a slight detour, and we're going to go and talk about, just because I think this is a good way to teach folks about Cilium, we're going to talk about how I tried to set up Cilium and Kubicorn and what I learned about how Cilium is working along the way. So how we're going to do that is we're going to go back to Amazon, and we're going to look at my Kubicorn cluster I created, and we're going to SSH into this master here, which also has a public IP address, and this is running Ubuntu 18.04. And notice how I have this nice side-by-side here, so we're actually going to be able to do stuff on both the COPS deployment and the Kubicorn one as well. Okay, so SSH Ubuntu at our public IP address there, and then I will sudo up. And from here, I think I should be able to kubeadm get PO. Okay, very good. So does that work here? Okay, good. So we have kubeadm on both Kubicorn. Can I actually, I want to like change my terminal prompt here so you can tell. Just try to remember Kubicorn's on the left and that COPS is on the right. Anyway, if we do alias k is equal to kubeadm, because I am super lazy, we can do kgetpo namespace cube system. And I'm going to scoot this over a little bit so it's nice and pretty for folks at home, and maybe zoom out a little bit and resize. Still not quite there, but that's okay. Here we have our Cilium pods, which are running in a daemon set, which if you remember when we looked at Calico last week, there was a daemon set that went and configured our host system for us. Cilium's deployment is the same way. The issue that we ran into is that the Cilium deployment here has this config map. So we can do a kget config map, namespace cube system, and this is where Thomas, who's been super helpful and it like gave me like a hands-on like personal walkthrough of BPF, helped me debug this for a few hours yesterday, and we ultimately just kind of discovered like TLS was just a big pain, and it just made more sense just to go with kops because really we just want a Cilium cluster up and running. Anyway, we have the Cilium config, so we can edit this really quick. Kedit, actually, before we do anything, export editor is equal to Emacs. That's a big deal. So now we can do kedit config map cilium-config namespace cube system, and we can take a look at this config map here. So if you go and you read the Cilium docs, we were messing around with this etcd config here, and you can sort of see this snippet. And if you deploy Kubernetes with kubeadm like kubecorn does, and if you look at the kubeadm config file, actually I can just do that really quick, etc kubecorn kubeadm config, we actually don't specify any of the etcd override parameters here. So you get an etcd that is TLS encrypted and has auth turned on. So Cilium needs an etcd data store to do some of its magic behind the scenes. So part of installing Cilium involves pointing it to the etcd that the Kubernetes control plane also uses. In this case, we ran into some trouble because the TLS certs were only valid for localhost. So when we tried to connect from a pod to that etcd server, those TLS certs were invalid, and that's why those pods are in crash loop backoff. And I'm not an etcd expert by any means, but when I thought about going through and actually regenerating some certs and resetting up etcd, I was like, this seems like a lot of work. So I'm going to use the kops install that had everything nice and neatly done for me. But it was interesting to learn that yes, Cilium does have a data store, just like Calico, and yes, it's using etcd. And if you remember in last week's episode when we looked at Calico, there was 2 different ways you could run Calico, which is either using the existing etcd that Kubernetes uses or to deploy it with its own. I think we deployed it with its own. And then just a heads up for folks that according to Thomas and folks in the Cilium Slack channel, which we're going to talk a little bit more about that later, there is an etcd operator that solves all these problems that's coming out, I want to say in the next version of Cilium, if not very soon. And so that way you don't have to go in and manually do all this and fight with TLS certs like I was doing. Anyway, just a heads up for folks, I kind of went down that rabbit hole, and that's where I got. So if you're looking at doing any sort of custom Cilium deployment, feel free to ping me or Thomas, and we can talk about like what we learned when we went through this, and talk about maybe some ideas we have. We got pretty creative with curl and trying to figure out how to authenticate and verify that our TLS was actually causing the problem that we ran into. And just for good measure, let's do a git pods and namespace cube system. I'll just show folks the log line that we are running into so you can see where we got. So here, kubeadm logs, the name of our pod, namespace cube system -f. Okay, so you can see Cilium is starting. Right here, this check, if you remember earlier, I talked about it does a kernel check right out of the bat. So, I mean, the program would start, it would do a kernel check and exit right away, and the pod would go into crash loop back off. And using that -- previous was helpful to actually get the logs that said, oh no, you needed a kernel greater than 4.8. So then it does some BPF requirements, and the BPF file system is going to be mounted automatically. Okay, this is another thing I forgot to bring up. If you go to the Cilium documentation, there is, let's see if I can find it. Might be getting, is there like an introduction, integrations, Kubernetes? Quick start. Here, this is the command here. So in my kubecorn bootstrap script, I added this to run on every master and every node, and there's examples of the bootstrap script in the TGIK repo under episode 47. But you got to mount the BPFFS file system in order to, I think it's for data preservation, so that like, and I'm speaking out of turn here, so somebody from the Cilium side can help me a little bit more. But I think in order for some sort of BPF to persist, you want to make sure you have this file system mounted. Otherwise, like every time you deploy a new pod, it like has to like reset something along the way. So this was a command that I definitely wanted to turn on whenever I was setting up Cilium using kubecorn. So make sure that you know that as well, so that you don't get this error right here that I have, or this warning right here that I have highlighted. Okay, and so it mounts it, and then it says unable to set up key value store. Error, open, blah, 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 no such file or directory. Okay, and this is actually not the error I wanted to show you. This is just me hacking on it a little bit after I got home last night. I was trying to mess around with some other configuration values to see if I could get something working, but ultimately I think it said something along the lines of context exceeded, and that was a sign that our TLS was actually incorrect. So anyway, setting up Cilium is it's a bit tricky at first, but once you get it, it's actually a really fantastic tool and a really fantastic plugin that we're about to take a look at. So I'm going to get out of this Kubicorn cluster, and I'm going to leave it online in case folks have any questions about it moving forward. And we're going to kind of like re-transition over to our COPS cluster. And we're going to look at deploying a pod in Cilium, and then I want to do a little bit of the network policy and then look at some of the Cilium CRDs and go through some of the tutorial stuff here as well. So I guess to start off, one of the things I wanted to demo was the fact that Cilium comes with this really cool command line. So how we can do that is we can do kubeadm, get pods, namespace kube system, and I guess I can do this from my host as well. So let's actually do this. kgetpo namespace kube system, and that way we're going to save ourselves the network hop when we exec into one of these pods here in a second. So there's 2 pods running in the daemon set, one for each of our machines in our cluster. If you remember, we had 1 master and 1 node. So these are the 2 pods here, and you can actually run this owide command and actually see where things are running. So run our previous command and do owide. This is handy if you ever need to figure out where your pods are running. You actually get an IP address here. It's kind of cut off right now. Let's see if I can expand this a little bit. Maybe if I do this, we'll just cheat. Okay. Yeah, and you can get the IP address and then go and map that back to Amazon and see what's going on. Okay, so if we get our pods again, we can exec into this first Cilium pod. And how we do that is we're going to do kexec interactive tty, the name of our pod, and the name of our cube system, the name of our namespace, which is cube system, and we want to run bash. Okay, so here now we're exec into the pod, and you can actually just run Cilium out of the gates, and like poof, here's a Cobra command written in Go. So this was really easy, and got me kind of excited about like all the cool things Cilium can do behind the scenes. I guess when you install Cilium, it like learns about Kubernetes, it bootstraps itself, and it will actually go through and sort of do all the magic for you of registering itself as a CNI provider and reconfiguring the kubelet to recognize it as a CNI provider. And if that wasn't enough, you get all of these extra goodies here as well. I was on the phone with Thomas, and I asked him if there was a good way to like gain some visibility into what's actually going on behind the scenes with CNI and Kubernetes, something I kind of struggled with Calico. And Thomas mentioned there was this really cool command here I wanted to show people, which is like TCP dump for Kubernetes. So this was really exciting. So you can run Cilium monitor, and then I found out there's a verbose flag here as well, and you can run this and you actually get why is that not working? Cilium monitor. Maybe it was a different command, but you actually get like network information as things are running on the network. Let me run this really quick again and deploy a pod and see what happens. Cool. Oh, there we go. Okay, so now I don't know why it was hanging before, but like each one of these records here is super verbose, and you get all this information about what Cilium's doing behind the scenes. And we're going to go through and we're going to learn a little bit about how Cilium works when we actually look at the BPF stuff a little bit later in the episode. I just want to give folks an idea of what's actually going on in Kubernetes firsthand and let folks know that we do, in fact, have a handy-dandy CLI tool here. Okay, let's see what else we have here. Sometimes I will just like get bored and I'll just like run command line tools and just be like, oh, what is all the cool stuff it can do here? So if anybody has anything they would like for me to check out and explore, feel free to drop it in the chat. And let's go and let's talk about how Cilium works and talk about endpoints and IDs really quick. So let's go back to our docs. And I think I had it here. Cilium endpoint list is what Arvind says. So yeah, I think I want to run that command, but I want to run it after we kind of like go through the docs and actually learn what an endpoint is first. But that's one of the ones that is definitely on my list here. Thank you, Arvind. So let's see, where is my documentation here? Okay, so we had the install guide that we looked at. This is a really cool article that as I was starting to get into Cilium, I noticed this thing, and this is sort of talking about Cilium and BPF in general, which is probably important to understand that Cilium uses BPF instead of IP tables. And there's some reasons for that, and there's some pretty compelling metrics and support around BPF in general. I'm not an expert on this specific low-level networking, these concerns. So, I encourage folks to go explore BPF, to look at IP tables, and to remind themselves that if you are looking at tools like kubeproxy, that there's a good chance that using something like IP tables for load balancing isn't always the best idea. So make sure that when you're doing your metrics and your side-by-side, you're looking at really nice, complete implementations, and one of which I feel like Cilium is a great BPF implementation. So it's been nice over the past couple of days to learn about BPF and how it works. So anyway, this is a really cool article if you want to come check it out. And then, of course, the second I saw that Jerome was on here, I was like, okay, I got to come read this thing. So as I'm going through that, I'm learning about BPF, and I wanted to understand what these endpoints are to Cilium and how they are relevant to Kubernetes. So let's see if we can find policy code. I thought I linked it in here, but maybe not. Let's just go look and see if we can find it. There was really good documentation on Cilium endpoints. Let's just search here and see what we can see. Endpoints. Searching, concepts, component overview, Cilium agent, Cilium CLI, we've looked at that. Linux kernel BPF, Berkeley packet filter, which is what BPF stands for, and this talks about, so this is what we were just talking about earlier. Not endpoints, but relevant, and this just talks about how we need a kernel greater than 4.8. It talks about how you need a key value store to use it. I want endpoints. There we go, endpoints. Okay, I'm going to kind of do a little bit of read the docs here online because I think this is an important concept for folks to get as we move forward. So Cilium makes application containers available on the network by assigning them IP addresses. Multiple application containers can share the same IP address. So this is important. As we expand our replicas, it looks like they're going to be grouped in the same endpoint group using the same IP address, which is handy. A typical example of this model is Kubernetes pod, which you can scale that horizontally using replicas. All application containers which share common addresses are grouped together, what Cilium refers to as an endpoint. So an endpoint is a logical grouping, and again, I'm counting on folks at Cilium to make sure I'm getting my vernacular right here. So an endpoint is a logical grouping of one or more pods in a replica set, and the rest of the Cilium network kind of treats those pods the same way. And that is relevant to Kubernetes because that's how we're going to identify these and how we're going to be ultimately be able to enforce things like network policy. Remember, network policy is this ability to govern which pods can and can't talk to each other based on labels, which I have a little bit of a tutorial we're going to go through at the end of the episode that shortly gives an example of setting up a network policy with Cilium and actually comparing the Cilium network policy to the Kubernetes network policy, which is a pattern that we also saw in Calico, which was we have the Kubernetes network policy, which is a very simplistic object in comparison, and then we have this more complex, more feature-rich network policy that is specific to our CNI plugin. In this case, it's called a Cilium network policy. The big difference between the Cilium network policy and the Kubernetes network policy is that the Cilium network policy is able to span up to layer 7, meaning that you get this finer grain of control over, I would like to only accept GET requests on endpoint/foo with pods matching label bar. And that sort of goes beyond the scope of network policy in Kubernetes. And we can look at setting one of those up in the documentation a little bit later when we do our tutorial. Anyway, I'm going to keep reading about endpoints here. Allocating individual IP addresses enables the use of the entire layer 4 port range by each endpoint. I'm going to skip ahead. The default behavior of Cilium is to assign both IPv4 and IPv6 addresses to every endpoint. However, this behavior can be configured, and the same behavior will apply to regard the rules, load balancing, etc. And you can see address management here. One other point I wanted to bring up, Arvine has saying something in the chat. An endpoint is equal to a group of containers, i.e. just a pod and case, which unites pods is identity ID. Okay, so we should read about the identity here as well. So for identification purposes, Cilium assigns an internal endpoint or an internal ID to all endpoints on a cluster node. The endpoint ID is unique with the context of an individual cluster node. So I think what we're saying here is that Cilium is going to assign an ID to the endpoint, and that is how we're going to be able to recognize it and do finer control over which pods can talk to other pods. And for folks at home, it's important to remember that whenever you schedule a pod in Kubernetes, that's when we call out to the CNI plugin, and the CNI plugin's responsibility is to set up our network for us. So let's do our CNI endpoint list and see which endpoints we have running in Kubernetes. So we can go back here. Remember, we're execed into a pod here in this, and we can do Cilium. I think that's, nope. If you look here, I got back to my host. Okay, so let's run our exec command again. Now we can do Cilium endpoint list. And we can actually see that we have some endpoints here. Let's see if I can expand this, make this a little bit prettier. Okay, why my terminal is just not wanting to cooperate today. Let me get out of this one here. Exit, exit, exit. And let me zoom out, bam, bam, and then resize. Okay, that makes it a little bit easier for folks to read. Okay, so here's our first endpoint. And I noticed earlier when I was poking around at Cilium, if we get into the other pod, we actually see different set of endpoints. So I think we did this first one. So let's try to do the second one. So what do we have here? It is S6. This is the value I'm typing here. So S6X. Wow, that's hard to say. 5H. So then we run bash, and then we can do a Cilium endpoint list. And if you see here, we have a whole other set of endpoints. So this is important to call out that we're seeing endpoints defined on the node level. And here it's a lot more interesting. I'm assuming the reason it's more interesting is because this one that we just execed into is actually running on a node, which actually has workloads running on it. So we're actually getting to see a lot of these endpoints here. And I know I just closed my terminal, but I wanted to reopen it here in a different window. We're going to see where the rubber meets the road for these endpoints. So let's scroll in and resize, and let's grab our node IP address out of Amazon again. So Cilium cluster node, copy this back to our terminal, SSH core at, did I grab? Yes, I did. I want this one. I grabbed my kubecore node. I want my cops node. Nope, I did that backwards. There we go. And we can do sudo bash, and we can go to var run Cilium. And if you come in here, there's this state directory, and this is really cool. This is sort of, this. When I saw this, this obviously reminds me of /proc on the Linux, on a Linux file system, but we're actually seeing these IDs here. And if we go back here, I bet if we look, we can find 13949. If we come back here, sure enough, we have 13949. So we have an endpoint defined, and I'm assuming this is all stored in etcd since this is the key value store that Cilium uses. We have an endpoint defined, which is how Cilium is grouping together its containers with a unique ID. And then in this directory, we have some really interesting things going on here. So for this endpoint, we can actually see that we have a couple of files here. This first one is an object file called bpf_lxc. We have this configuration file, and we have lxc config. It's a header file. And I know what you're thinking, like, this is all written in C. Let's see what Arvine says here. He says, 2 Prometheus pods have the same identity in that endpoint list in the Cilium X6, X5, I think. So let's see. He is saying 2 Prometheus pods have the same identity. So I'm going to expand this so it gets a little bit cleaner here. Okay, so here we have a Prometheus pod, and I'm assuming we have another Prometheus pod here as well. Yep, okay, so what he's saying is this is really cool. Okay, this is really awesome. Thank you for bringing this to my attention, Arvine. Okay, so we have this pod, which has identity 20274 with endpoint 13949, and we have the same identity here for this Prometheus pod, but it has a different endpoint. So that's letting us know that Cilium can treat those 2 pods the same. I bet if we looked, they're running as a replica set. Even though they have 2 unique endpoints, they share a common identity. Oh, okay, Arvine says it's based on the labels. Okay, so everything in Cilium is label-based. That's really cool. I am curious about these Prometheus pods now, so I just want to see like what's going on so we can connect the dots here. So let's do, I love hacking, you guys. Like the fact that I just get to hack at work on Fridays, like this is so much fun. Also, I like talking to myself, so the fact that I'm just in this room talking to myself is also a lot of fun. Okay, so let's do kgetpo. I'm assuming that is in, yeah, if we look here on our labels, namespace cube system. So namespace cube system. We have 2 pods. Do we have Prometheus pods here? Where are these Prometheus pods? Okay, so I'm going to do my show me everything in Kubernetes command, which I think, is it still defined? No, it's not. I did tweet about this the other day. But you can do a kget all -- all namespaces, and this will actually show you every object that's running in your Kubernetes cluster. It's pretty handy for moments like now when you have a smaller cluster and you just want to see all the things. So this is all the things running in my Kubernetes cluster, and I bet if we look in here we can find Prometheus something or other. I don't see Prometheus. What's going on? I was assuming Cops did something and set up Prometheus for us, but I have no idea where we're getting those labels from. Let's see if we can find any more clues up here. Okay, so we have this pod namespace. Oh, it's in the kubeadm autoscaler. Okay, that's that pod. Then we have annotation Prometheus IO port. Which pod is this though? Okay, there it is. It's kubeadm and kubeadm. I don't know why we have Prometheus labels there. That was confusing me. Okay, so if we come back down here we have kubeadm, and I bet if we look, we can find a kubeadm deployment, and replicate count, of course, is set to 2. So to review, because I feel like this is important for folks to get right, we have a deployment called kubeadm. In the deployment, we have a replica count set to 2. Because the replica count is set to 2, we get 2 kubeadm pods here and here. When we exec into the Cilium pod, with Cilium, we can do a Cilium endpoint list, and we can actually see that we have the 2 kubeadm pods here and here, which have a matching identity so that Cilium treats them the same because they're in the same replica set, but have unique endpoints. Furthermore, if we actually go onto the node that the kubeadm pods are running on, we can actually see in the var run Cilium state directory, we have 2 directories for the endpoints, not the ID, that match the kubeadm pods as well, which we're about to sort of learn about what is in these directories and why it's important. Whew, okay, that was a lot, but I think that should connect where the rubber meets the road, going from Kubernetes pods all the way down to a C program on the underlying Linux file system. So we're going to come back up about 2 or 3 levels mentally, and we're going to look at some C code. Actually, I don't know, does that count as coming up levels mentally? But I did want to show folks in the repo the C code and show folks exactly how explicit Cilium is at rejecting traffic here. Jonas says, what's in the globals dir? Let's go find out, Jonas. I don't know. Change directory into globals. Actually, before we do that, let's list globals and make sure everything. Okay, that's not horrible. So change directory into globals. We have 2 header files here. Let's open them up. Actually, just because it's a new program that I don't know, I'm going to be very cautious. And we're actually going to see if these are actually, oh, file not found. What? apt-get install file. Oh, it's CoreOS. Okay, I don't even know about CoreOS. This is my first time ever using a CoreOS image. Anyway, I'm just going to assume they're header files, and if I break my terminal or break the computer, then we'll just restart it. Okay, so Emacs, and let's do bpf features.h. Emacs not found. Ugh. Okay, can somebody tell me how to install Emacs on CoreOS, please? That would be helpful. But we can use cat for right now. bpf features. Okay, it looks like we just have some simple variables defined here. And let's look at the other file, which is node config. Ooh, there's a little bit more going on here. We have some commentary at the top, and it looks like we're defining a lot of just values that you see in header files commonly. I don't know what any of this stuff does, but it looks important, so I probably wouldn't mess with it. I'm sure our friends at Cilium who are on the call are happy to explain why these two header files are and how they're relevant to the rest of the C code that we're about to look at. I'm not going to go very deep into the C code because I feel like that's going to take a long time to go through. Oh, yes, Miguel has my Emacs command. But I just, again, wanted to show you guys that Cilium right out of the gates will reject network traffic based on some really interesting features here. Let's see what folks are saying about CoreOS. Miguel says DNF -y, install Emacs Nox. Daniel says BPF features, the header file, is generated from probing the underlying kernel of available BPF features. Okay, so I think what he's saying is we probe the kernel, we see which BPF features are available, and then we define some sort of like configuration for the rest of our C program when we build it later. Okay, because the way that BPF works is we're actually building these small, I'm assuming it's the object file that gets built, but we're going to look a little bit more later at that after we look at the C. But I'm assuming, I know some sort of bytecode is generated, and that generated bytecode has to be compiled, so I'm assuming it's going to reference these as well based on what the kernel supports. I have a feeling that's what's going on. Daniel, if you want to +1 that or not, or correct me, please feel free to. Paul says CoreOS purposely doesn't have a package manager, so apt install or anything, but could drop an Emacs binary there. Todd says, yeah, CoreOS is very stripped down. Use more, less, cat grep and VI. It's about your best options. Y'all don't want to see me open up VI on TGIK. That would just be embarrassing. And Daniel says, yes, that is correct. Yay, I got something right. And Paul says, also, I think there might be Nano on, oh, there's Nano on CoreOS. I love Nano. Nano RC for life. So let's see what we have here. Node config, no, Nano not found. Dang it. It's okay, I can use cat and less and grep. Like, that's totally fine. I might even use sed if you guys are very, very lucky. Okay, so where was I? Let's go up a directory. Here we were again. I'm now kind of curious what's going on here. We have this netdev config.h. We have a couple of other object files. Oh, there's a log. I love a good log. BPF, features.log, kernel config not found. Okay. So yeah, there's some sort of BPF log running there as well. Oh, Paul's sad face because Nano. That's okay. I'm going to actually try Miguel's Emacs command just because I'm all about blindly dropping commands on cloud servers because I feel like it's safe to do it because it's in somebody else's data center. DNF not found. Okay, so no Emacs on CoreOS. It is a sad day for this girl. Let's go and let's look at the C code in the Cilium repository and hopefully learn a little bit more about BPF and how BPF works. So, go here. I want to go back to my documentation, and here's this link in our docs, Cilium C code. So in the Cilium repository, github.com/cilium/cilium, we have this BPF directory, and if you come in here, you'll actually notice that this is all written in my personal favorite programming language, C, which really is every programming language if you think about it. Anyway, the rest of Cilium is written primarily in Go, but there's this little BPF section here that is written in C. Okay, so the first file I wanted to look at is this bpf lxc.c file. Again, we're not going to go super deep into the C code here, but if you scroll down, you can see that we are actually including quite a bit of the Linux source code here, especially the stuff around networking. If you've ever written any like Linux network code before, you're probably familiar with some of these lib files here, particularly this one, our good old friends at IPv4 that we've been using for forever, and there's some other ones as well. So we come in here and we scroll down, and there was actually, let's see if I can find it. This section here jumped off the page at me when I first came and started looking at the source code. It says, check if the destination address is among the address that should be load balanced. Wait, that's not the one I wanted to bring up. I wanted to bring up this one. Okay, it was this one here. If the packet is in the established direction and is destined within the cluster, it must match policy or be dropped. When it says must match policy, I'm assuming this is actually where we do the network transaction, or we either approve the network transaction or we reject it as well. And I'm curious, Daniel, maybe you know the answer to this. what exactly are we checking here on this policy can egress? Is this actually checking the Kubernetes or the Cilium network policy, the Kubernetes network policy, or something entirely different altogether? This was just an interesting piece of code I wanted to pull up and take a look at. What's going on here? Oh, sorry. My partner is texting me. I guess they're out of the wilderness. Anyway, interesting to hear if you can give us a little bit of clarity here. Daniel. So it's checking the Cilium policy. Okay, and we're going to run a Cilium network policy example here after we get done looking at these files here on our file system. So to recap, we create a pod. We have 2 pods. We're going to continue to use our kubeDNS example. We have 2 pods kubeDNS. They have unique endpoints, which are listed here in state, and they have a shared ID. And then we're compiling some code in each of these directories here. The Cilium pods are compiling these code and spitting out this output for each one of our endpoints, which is, again, unique to a pod. And then we're using this. I'm assuming that the binary here in opcni bin, I'm assuming that there's some tool here that is actually going to call out and run these independent binaries as needed. But again, Daniel, if you could help us connect the dots there, that would be helpful. Also, Daniel, thank you for joining the call and helping me walk my way through this. Autome says, and I would expect Cilium would base its policy on Kubernetes policy for networking. Daniel says, the C file is basically compiled into BPF instructions and loaded into the kernel's networking data path. Okay, so we're getting pretty low level. The important thing here is that Cilium is based on endpoints and identities, and you don't see that in some of the other CNI providers like Calico, where we're using IP tables that are not nearly as built on this concept of identity and rejecting that at such a low level in the network transaction on the file system there, or on the host system. Ugh. Anyway, let's look at running a Kubernetes network policy example and look at creating a Cilium network policy example. So here in the docs, that's just the CNI bit there. Now we're going to switch over to network policy and look at how all of that kind of works. So to go back into the docs, we have 2 pieces of code I wanted to look at. This first one here is layer 7 with Cilium, which I was really excited to run this live on the air because I haven't ran this yet, and it's totally Star Wars themed. Oh, not the layer 7 one. I opened up the wrong one. This is the one I wanted to open up. Nope. I can get to it from here, it's okay. Actually, you know where it was? It was in Slack with Thomas. Let me jump back into Slack and pull this up really quick. So speaking of Slack, there's 2 links here. I totally have been hanging out in the Cilium Slack all day today and all day yesterday, and I forgot to mention in the last episode, there's totally a Calico Slack as well. So if you're interested in learning more about these, there's 2 Slack channels there, and let me find this link to this documentation that I wanted to run through as well. Okay, here it is here. So I'm going to move this all the way over so I remember it. Oops, I accidentally turned on my own TGIK video. Okay, so we're going to run through a little bit of this, and I also want to run through this test as well. I was thinking to myself, we did this when we did Calico, and CNI providers should behave the same with network policy. So this is a good example that we can just sort of run through in about 30 seconds or left and actually do like the Pepsi challenge where we run the exact same code and we make sure that Cilium is working as expected. So if we run through this, and I know folks are saying stuff in the chat, so like give me a second here to kind of like go through this and then I'll check and see what you're saying. Also, still wondering where that Friday beer is at. Cough, cough, Heptonians, cough, cough. So how we want to do this is we want to run it on my laptop here. So we'll create this policy demo. We want to run this pod, and I'm going to skip over some of this just so that we go through it a little bit faster. So we create our Nginx pod, and that's what we're going to use to validate that network policy is working as expected. And we're going to create a service for that by running this expose command. And now we're going to run this command here and just demonstrate that it works. And we're going to run this wget and use kubeDNS to try to hit that Nginx pod we just created. And poof, it works. So scrolling down, we can now enable network isolation, which this is relevant. We talked a little bit about it last time, but this is how we start to basically enable Kubernetes network isolation so Kubernetes network policy is even relevant in the first place. So let's exit out of this pod. clear my screen. We'll create this empty network policy rule here, and that's how we turn on network isolation. It's a bit of a weird pattern, but that's just how we do things in Kubernetes, the weird way. And now we can run this command, and we'll SSH into our new pod, and we will now time out. Bam. And it's timing out now. Okay, and why that's timing out, I'm going to look in chat and see what folks are saying. Okay, so scrolling up, Daniel says the C file is basically compiled. Okay, we already read that one. Arvine says yes for Kate's network policy, and there are extensions for L7 and DNS-based policies. Oh, cool. I didn't realize that Cilium did DNS as well. That's exciting. Thomas Graf says the point of the C code is enforcing both Kate's network policy and the Cilium network policy. Okay, so Thomas brings up a good point, which there's a difference between the Kubernetes network policy and the Cilium network policy, which the Kubernetes policy is what we're looking at now, and this is just a really basic example to kind of show how it's going to work, and that we're going to demonstrate that Cilium is respecting Kubernetes network policy, and then we're going to look at actually creating a Cilium-specific network policy and look at some of the cool examples of things you can do with Cilium on top of base Kubernetes network policy. Thanks for that note, Thomas. Ian says Cilium watches for Kubernetes network policy. Yep, Ian's just validating what I just said. When these are added to Kubernetes, Cilium is notified by Kubernetes and computes the policy based off the rules that apply to each endpoint. So as we change network policy, Cilium is going to be reactive to that and is going to update the BPF implementation as needed to respect Kubernetes network policy, which that's pretty cool. Ian also says the policy that applies to the endpoint is converted to a representation that the data path can understand from there. Also, wonderful information. And thank you again, folks, for joining and helping us out as we explore Cilium. Okay, so our request timed out as expected. We have network isolation turned on, and we haven't created a policy that says otherwise. So how this whole thing works in Kubernetes is we create this empty network policy. It turns on network isolation implicitly. And now everything is sort of deny all, and you have to explicitly go in and say, no, please open this up so that we can actually begin to use that now. And that's what we're going to do in these next few steps. Whew, I told you guys I was going to have a lot of sugar today. I feel like I've been talking really fast. Better have some more. Okay, so now we create this network policy. And again, hats off to our friends at Tigera and Calico. This is still my favorite example of Kubernetes network policy anywhere on the internet. So this is one of my favorite things to demo. So thanks for letting us steal it for both episodes, and we'll probably continue to use it for other CNI episodes as well so that folks always get a side-by-side. Okay, so let's exit out of this pod. Let's create our new network policy here, and it wouldn't be TGIK if we didn't look at YAML. So we have our match labels run is equal to Nginx. And if you remember earlier when we created our Nginx deployment, that label run is equal to Nginx is implicitly created because the name of our deployment was Nginx. So we know that that label is going to match. So we create this, and it says access Nginx created. Come back here, and now we have these two commands here. So I'm going to kind of set this up so we can do a real quick side-by-side. We have this one. See if that works. Okay, and let's copy this one. I know I'm doing it backwards, but trust me, it'll make sense in just a second. Exit out of this, run that one, and now let's grab our wget command here. Okay, so this is cool. So let's clear our screen and let's look at our two commands that we have in our buffer here. The first one is we have can't access here, and our next one is we have access. So if we run access, see, I'm thinking ahead, this is why I did this. If we run access and then we run our wget, we can see, oh, I don't know why I have that copied. Let me grab my wget here. Bam. And you can see that, yes, we do, in fact, we get a response. And when we run our can't access, which will have a different label, it won't match. And when we run our wget, it will ultimately time out. Okay, so let's look what Cilium is doing behind the scenes. So if we come here, I have no idea what changed, but I bet our friends at Cilium, Ian or Thomas or Arvine, can let us know what happened here and if anything changed in our file system. But somehow Cilium was going through and actually creating that network policy and actually changing things, I'm assuming, in this directory to respect that new network policy we just created, and that happened while we were running all of these commands here. So we can now validate that Cilium is actually respecting Kubernetes network policy, which is good because that's one of the big things CNI is supposed to do. And we can actually go and see those network policies in Kubernetes, doing a kgit netpol. We'll do all namespaces. Okay. And you can see here in the policy demo, which we stole from the Calico documentation, we have our Nginx, which has pod selector run is equal to Nginx, and then we have this other one, which is how we turned on default deny for our isolation in the network to begin with. Okay, so those are the Kubernetes network policies. Now let's try to get the Cilium network policies up and running and look at some of the other examples there as well. And before we do that, I just wanted to point out for folks at home, you can do kgit crd. If you do not know what that does, it returns all of your custom resource definitions you have defined in your cluster. Here we have Cilium endpoints and we have Cilium network policies. So what's cool here is you can do a kgit, I think it's CEP for Cilium endpoint, -- all namespaces. And you can see we have all these endpoints here. And I'm trying to think, I want to compare that to an endpoint list, so give me a second here. Namespace, kube system. We're going to grab our Cilium pod, we're going to exec into this thing again. KExec, IT, the name of our pod, namespace, kube system, bash, and Cilium endpoint list. This dreaded terminal sizing again. Let's try this. Okay, so we're going to run our Cilium endpoint list. That's a little bit cleaner, and then we're going to exit out of this and run our all namespaces again. So we can see that we have endpoints defined across our cluster, and a subset of those endpoints are here, and we get a little bit more verbose information if we actually run it with the Cilium command line tool as we're execing into one of the pods. But again, important to note that Cilium endpoints are a unique ID for all these different pods that we're running. But that's sort of how this whole system sort of works together, using CRDs, using the underlier and etcd data store, and baking all this into Kubernetes. So it's kind of cool to see a CNI provider that actually uses a lot of the underlying resources of Kubernetes, like CRDs, to actually bring themselves to life, which is pretty exciting. Again, this sort of like echoes the sentiment of Joe's Kubernetes as a platform message that he's always talking about. Anyway, Thomas has a comment for us. He says, the Go portion of Cilium has received the new policy, calculated what security identities this maps to, and then pushed down rules to the BPF map to allow these identities. This is different from other CNI plugins, which map to IP address-based filters. I could not have said that better myself. Thank you, Thomas, for that wonderful explanation. When he says the Go portion of Cilium, I'm assuming that he's talking about the Go program that is running in this pod here that we just execed into, and then that's pushing down accordingly. And we're doing all of this based on BPF map and endpoint and identity instead of IP addresses. So we're getting a little bit more secure and a little bit more flexible of how we do CNI implementation here. So Todd says, does kgit CEP all namespaces O wide maybe give more detail closer to the Cilium output? That is a great question, Todd. Let's run that and see. So we'll clear our screen using our Control-L that we all love to use. And we're going to run this O wide. No, it doesn't. But that's cool because we know that we have the Cilium command line tool there. And I guess this begs a pretty interesting question, which is, would it be possible to configure the Cilium command line tool to work from my local workstation here, or do I have to be execing to the pod whenever I want to use it? I'm assuming there's got to be some sort of like centralized API server or etcd somewhere, and I'm wondering what you would have to potentially expose in order to get the Cilium command line tool working outside of the cluster. So yeah, if you could give us any information there, that would be helpful. Okay, and last but not least, we're already an hour and 13 minutes into the episode, so I don't know how much time I'm going to have to actually go through this, so we might actually just kind of go through it really quickly here, and then we'll get off for the day because I have a 10-day mountain climbing vacation that starts the second I hit the stop streaming button in YouTube here. I still have to go to the doctor and get my hand checked out, but I'm getting excited if you guys can't tell. Few folks can't tell. Okay, so let's go back to our documentation we wanted to look at for our final little bit of Cilium hackery for the day. Okay, so we're going to kind of start at the top of this snippet here. And you know what? I better add this to the hackmd because I don't think it is otherwise. So I think I come over here and I go bam, bam. So here's our link. And then we want to call this, I don't know what's going on. A lot of weird tab hinting. Cilium tutorial from end of episode. Okay. So there's that, and we can come back here. So we're going to go through this. First, install Cilium, which we already did. Deploy the demo application. In our Star Wars-inspired example, this is the real reason I wanted to do this. There are 3 microservices, the Death Star, the TIE Fighter, and the X-Wing. The Death Star runs an HTTP web service on port 80, which is exposed as Kubernetes. The Death Star has 2 pod replicas, and what does the TIE Fighter do? Or the X-Wing represents a similar service on the Alliance ship. Oh my gosh, I love this so much. So here's how we would create this. And I've already gone through and I validated this YAML, and because we're kind of crunched for time here, we're going to assume that our friends at Cilium are in fact friends and not foe, and we don't have anything malicious in this YAML. Joe, I know you didn't see me do this, but I'm going to YOLO sudo pipe to bash here, or pipe to sudo bash here, but Kubernetes style, and we have a Death Star, a TIE Fighter, and an X-Wing. So going back to our docs, we can run get pods, and we can, I'll go ahead and run this for good measure, but we can get pods and services. This is another handy thing about kubeadm that a lot of folks don't know, is you can actually use a comma delimiter to get multiple resources at once. So we can do pods and services, and you can see that we now have Death Star pods, TIE Fighter pods, and X-Wing pods, and we have a Death Star service for our Nginx Death Star, which is handy. We can run kubeadm namespace kubesystem, get pods, and we can filter on labels apps equals Cilium, and then we can actually exec into our Cilium pod and then do a Cilium endpoint list, which we've already done that a few times, and you can actually see that we are getting Death Star and X-Wing endpoints here, so I'll do that now, but we'll do it sort of in context of our cluster here. So where was our exec? Bam, and we know this is our only node, so we know we're going to be able to find our endpoints here. And you know what? I really wanted alias Cilium equal to C. Can I like make a pull request to the Cilium repository that would just, so I could just have just a C here instead of the whole Cilium command? Would you guys accept that if I contributed it? Cilium endpoint list. And let's see if we can find any Death Star-y things here. Oh, here's a TIE Fighter. The organization is the Empire. That's a great label. And class is equal to X-Wing. And I bet if we look around even more, we can find, yep, there it is. Here's our Death Star here as well. Okay, so let's go back to our docs. Our Wiener Thomas says, yes, please. Actually, it looks like there's been a couple of comments in chat. Let me see what we have here. Thomas says Cilium 1.3 and Kates 111 will provide nice columns for Cilium endpoint. Thomas says, yes, please. I can open up a PR. Yay, I love contributing to open source. And Arvine says there are a few util scripts that you can run directly from the terminal in the troubleshooting section. Okay, cool. Any idea, Arvine, on where I would find those util scripts and how to run them? Just like a directory to check out would be helpful for me to navigate to. So let's check current execs. So let's see what we do here. So we exec into X-Wing, we curl, we do a post, and we hit the Death Star service on this v1 request landing. Okay, this is cool. So if you notice in this this curl here, we actually defined an endpoint. I bet later on when we get into layer 7, we can actually control some of the different layer 7 things and actually, like, when we hit the Death Star, turn on, like, yes, we do want to accept gets to the Death Star endpoint / request landing, but we don't want to accept posts there or something along those lines. So this is a great demo. This is probably my new favorite demo that I've done on TGIK. So thank you for making this fun for us by making it Star Wars themes. We really appreciate it. And I don't know why the dictionary keeps getting pulled up. Okay, so let's copy this whole command. And let's go back here and let's clear our screen so that folks get a nice, wait, where are we? I want to go back to here and kubeadm exec X-Wing. That should do it. And it says ship landed. Okay, and that's what we expect here. And then if we do the same thing on the TIE fighter, we also get a ship landed. I'm going to skip that for now and then name of saving time. So then it says apply an L3 and L4 policy. So when using Cilium, endpoint IP addresses are irrelevant when defining security policies. Instead, you can use labels assigned to the pods to define security policies. We'll start with the basic policy restricting Death Star landing requests to only ships that have label org is equal to Empire. Oh my gosh, only the Empire is allowed to land on the Death Star. This is great. And this will not allow any ships that don't have the org is equal to Empire label to connect to the Death Star service. And so here's how we do this. So here for API version, we have our Cilium 02, and for kind, we have Cilium network policy. Remember we saw those CRDs and those CRs earlier. We're actually going to go in and create one. And this looks very similar to Kubernetes network policy. In fact, if we look at the network policy in the Calico documentation, here you see that we have this ingress and we have a pod selector, and I think you can define egress as well. And if you come back to our Death Star example, you can see that we have ingress and we have match labels and endpoint selector. So instead of having like a pod selector, we have an endpoint selector, which again, endpoints are sort of the core of Cilium and how Cilium works. Okay, so we want to create this. To apply this L3, L4 policy, run this command. So let me, so this is a pet peeve of mine, and I want to know what folks think. So I know that everybody loves to put this little like $sign here to denote that this is running in your terminal. But my feelings on this are that it actually causes more problems because then I can't do the double click and select everything that's actually going to run in my terminal. And I think the fact that it's already in this little box here kind of lets me know that it's like a command anyway. So whenever I write docs, I never add the $sign there, but everybody hates me for it and always opens up PRs to add it anyway. But I, for one, am of the belief that we should not have the $sign there so that you always have a command you can double click and copy to your clipboard. And YOLO, I don't care what anybody has to say about that. Okay, so we created this new rule 1. Pneumatic said, agree, the $sign is redundant here. Yeah, I'm ditto. Paul enjoys as well. I wonder if we can start like a movement, like in open source documentation, like remove all $signs from documentation, hashtag whatever our movement is called. That would be cool. Anyway, so we created this rule 1 Cilium network policy. So let's do get Cilium network policy, and you can see we have rule 1, and let's do YAML on that. And we can see that it's actually gone through and expanded quite a bit. We have a lot more defined here than that was in our original definition. Let's see, Simon says, I think you can do it as a table with a $sign in a separate cell so that the double click only gets the command. Thomas, like a champ, PR is welcome. That's awesome. So anyway, let's look at this in a little bit more detail here. We have our endpoint selector, so any class is equal to Death Star and any org is equal to Empire. So whenever class is set to Death Star or org is equal to Empire, we're going to match on those endpoints. And for ingress, we're going to allow from endpoints with match labels org Empire on port 80. And then, of course, we have this fabulous status field here, which gives us a status of what's going on behind the scenes. So let's go back to our documentation. And it says, now if we run the landing request again, only the TIE fighter pods with the label org is equal to Empire will succeed. The X-Wing, the dreaded Alliance pod, will be blocked. So how we can do this is let's run our TIE fighter command here. So exec TIE fighter curl, we're going to do a post on this endpoint, and our TIE fighter was able to land on the Death Star. And if we come here, we do a kubeadm exec X-Wing on the dirty Alliance ship, and of course the Alliance is blocked from landing on the Death Star unless you're the Millennium Falcon, in which case we're going to suck you in and stick you on the Death Star regardless. Next, step 5, inspecting the policy. Okay, so we can actually go through and we can see that the policy enforcement is enabled here. So let's go through and actually do that. Anyway, we're hanging here, so I'm going to term our way out of there, and let's get our Cilium pod again here, and Cilium endpoint list, but I'm going to clear my buffer first, and I'm going to expand this so that we can get a nice readout here, and sure enough we have, no, we don't want that one. Here we go. So we have enforcement enabled on our Death Star endpoint here. So that lets us know that we're actually using the Cilium CRD to manage this endpoint. And then, of course, there's all of this wonderful BPF goodness that's happening behind the scenes that is making all of this happen. So Cilium has got this really nice, this layer of software on top of BPF that integrates well with Kubernetes that's making all of this happen. So that's really cool. So let's go back here, and it says you can also inspect details via kubeadm, so you can get here, which we've kind of already done a lot of this. We haven't run a describe on it yet, but we can totally run a describe just for good measure. I'm going to resize my terminal again, so I remember to keep everything on the screen. Nope, we don't want to be in the pod. We want to run on my local laptop. Describe CMP rule 1. So let's see, here's where our describe starts. So name is equal to rule 1. It's in the default namespace. We got our spec. We have some metadata about it, and we have status and no events. So pretty straightforward describe here. Nothing too crazy going on. Our veen says few utils here in Cilium contrib cates. Okay, I will go and check that out 1 second. Let me finish up this demo, and then we'll try to find that. Okay, Arvine? Okay, so step 6, apply and test HTTP aware L7 policy. So if we, let's read this here. In this simple scenario, it's sufficient to give the TIE Fighter and X-Wing full access to the Death Star's API or no access at all. But to provide the strongest security, least privilege isolation between microservices, each service that calls Death Star's API should be limited to making only a set of HTTP requests it requires to legitimate operation. So this is the bit that goes above and beyond the Kubernetes network policy scope. And this is where we get into the layer 7 of the networking stack, and we're actually able to define which types of requests on which endpoints and use Cilium network policy to enforce that as well. So let's run this command. For example, consider the Death Star service exposes some maintenance APIs which should not be called by random Empire ships. To see this, you can run here, and it looks like we actually get a panic, and it says the Death Star exploded, which is pretty hilarious. Okay, so we got to go panic and the Death Star exploded, which is funny because we all know how the Death Star really explodes, is because this is a great example. Like, the more I'm going through this, the more I love this, because Luke is able to shoot the missile into that tiny escape hatch that just so happened to be there on the side of the Death Star. So anyway, we were able to explode the Death Star, and here's a handy diagram about what's going on. And it says Cilium is capable of enforcing HTTP layer, i.e. L7 policies, to which limit the TIE Fighter. So how we would do that is we would apply this Cilium network policy. And if you look here, we now have this rules directive, which says HTTP method post, and I'm assuming this is a whitelist or like an allow only list. If our folks at Cilium want to let me know for sure. But this says that we can only post to v1 request landing. So how we apply this is, again, here, and we go back, and I'll clear my screen, and now we can apply this network policy, rule 1 configured, come back here, and if we do a kubeadm exec, again, we can verify that our TIE Fighter is able to land. TIE Fighter landed, and kubeadm exec TIE Fighter Death Star exhaust port. So this is how Luke Skywalker exploded the Death Star, and this should now be blocked by Cilium network policy. So we have sufficiently secured the Death Star from nasty Alliance attacks trying to shoot missiles into our exhaust port, and of course we get access denied now instead of exploding our Death Star from the inside out. Sorry, Alliance, you don't win this time. And you can observe the L7 policy via kubeadm. If we run describe Cilium network policies, you can actually see that we have these rules defined down here again, which I can run that in my terminal. So let's go describe CMP. You can actually see we have, we're blocking, so this is a block list, it's not an allow list. We're blocking this request landing, I think. Which endpoint are we blocking or not? No, okay, so we're allowing request landing, but it's implicitly blocked on the exhaust port. Okay, so it is an allow list. Okay, yes, correct. I put the link for everybody to run this demo for yourself in the Hack and D notes. Thank you, Thomas. And it says 7 cleanup, minikube delete. Okay, so anyway, that's it. That's Cilium network policies. Did we look at the other? Yeah, we looked at the endpoints CR. I think that's all I wanted to go over today. I'm going to grab some tea really quick. It's an hour and a half into our episode, So Friday afternoons, let me go and do the thing here where I go back to my face. So Friday afternoons are a great time for us to do this, and we thank everyone for joining. If you want to say your goodbyes, my lips are like so dry because I've just been talking for an hour and a half. Say your goodbyes in the chat. Any more questions you have for me, for Heptio, for Kubernetes, feel free to add them in the chat. And I'll try to answer them here. And I always like to spend the last few minutes kind of rambling on a little bit so that you guys on your end will get me saying goodbye and still have an opportunity to say something in the chat, and I can still respond. So I'm always like trying to find filler here at the end of the episode. I guess I can give a quick update on my vacation, which is exciting. So we're gonna go, me and my old climbing crew from Colorado, who I've been climbing mountains with for years, they're all flying out here tomorrow. And my partner who's been hiking the PCT, I'm going to pick them up in Oregon tonight. And we're all getting together. It's like a big family reunion. We're going to go climb up Mount Rainier, and I'm taking a week off work. And I literally think I have plans to just sleep on a glacier for like 2 days with my wonderful partner and my best friends in the whole world. And I think we're actually going to try to bring Charlie's ashes up to the top. So that's going to be really exciting as well. And this is what I do for my vacations. Anyway, folks say... let's see what they said. So Thomas says, you're awesome. Arvine says, thanks, Kris. This was awesome. Zolt says, thanks for the great demo. Have a great holiday. Pneumatic says, thanks, great demo. Simon, it looks like folks really liked the demo. More great demo comments. Paul, good to see you, Paul. Great episode. Be safe on the mountain. Totally. Olav says, bye and thanks. Daniel says, happy climbing. Miguel says, take care. Autome says, I only have one complaint about Heptio. I think they never got you a drink when you asked for it during a live show. It's okay. We still love folks at Heptio, and I can totally walk to the kitchen and get something. But I'm actually just going to get out of here because I'm so excited to go on vacation that I don't even want a beer anymore. So Olav says, no problem, keep cool on a glacier. So speaking of keeping cool on a glacier, I totally have a Spotify playlist for when I'm on glaciers, and it's got like Ice Ice Baby and like Led Zeppelin, like Come From the Land of the Ice and Snow, and it's just all songs about ice and snow, and it's really fun to listen to, and it's really hilarious. So Mozufer says, great demo. I joined late today. And Tobias says, thanks, Kris. Enjoy climbing. So again, thanks for joining. This was one of my favorite episodes to do. I had a lot of fun learning about Cilium and exploring CNI and Kubernetes. And the folks in the Cilium Slack couldn't have been more helpful along the way. I felt like I got a little bit of the white glove treatment. So thank you so much for that. So update on next week's TGIK. So I think Duffy, who will be our third TGIK presenter here at Heptio, is going to try his hand at doing a TGIK from Linux next week. I don't think he's going to be here in the Heptio studios, but make sure that you join and show our support for Duffy, who's he's one of our field engineers. He's a great guy, really smart. I've learned a ton from him about Kubernetes, and I ask him questions regularly, and he, like, even before I jumped into Cilium, he was already telling me all these great things about Cilium and what he liked about it. So join him next week. Joe and I are both going to be out of town. He will be on the side of Mount Rainier. I will be on the top of Mount Rainier, hopefully. And it's going to be a great time. So join Duffy, and I think he's doing a TGIK on Harper, I want to say. Anyway, thanks, everyone. We will see you all when I get back from vacation in 2 weeks. All right, bye.